So let me do an example. I'll do an indefinite integral of 1 over square root of 2x squared minus 3x plus 5. And then the first thing to do is going to be to complete the square. So I look at 2x squared minus 3x plus 5, and I do that simple algebra. That has nothing to do with the integral. So how do I complete the square? I factor 2. I end up with x squared minus 3 halves x plus 5 halves. Then I make a complete square inside the brackets. It will be a square of x minus 3/4. And then I still have this 5 halves, but I have to subtract the square of 3/4, 9/16. And then I bring that to common denominator, multiply by 2. So I have 2 times x minus 3/4 squared plus 5 minus 9/8. Let me simplify that to the common denominator 8. It will be 40 minus 9, so 31 over 8. Now what I want to see here is something like a square plus or minus 1, right? I will definitely have plus 1 after I factor that number. So I'm factoring out exactly that number to get 1. 31 over 8 is factored, and then inside I get 2 divided by that number, which means 16 over 31 times x minus 3/4 squared plus 1. And that's basically the end of it, in the sense that I see 1 plus a square. And that's the goal of my substitution, to make all that expression a square of one variable. We call it u. And then I'll figure out what u must be from this equality. So this is what I want. I want to see 1 plus u squared. And that means that u is the square root of all that. So square root of 16 over 31 times x minus 3/4. And then I can solve for x if I want. So what is x from there? X is square root of 31 over 4 times u plus 3/4. So this is the substitution, a linear substitution. You can always do the linear substitution, so let me do it. What happens if I substitute that? Well, first of all, what happens to my integrand? Because I definitely know what happens to dx. Dx is that coefficient, square root of 31 over 4 times du. That's easy. So what happens to the integrand? It will still be a fraction, 1 over square root. What do I have inside the square root in terms of u? I'll have exactly that. So all that will be inside the square root. So 31 over 8 times u squared plus 1. multiplied by this square root of 31 over 4 du. And now I can pull out those constants. Square root of 31 over 4 from du, and that square root 1 over square root of 31 over 8 from the integrand. And what I have left is 1 over square root of 1 plus u squared du. And this is exactly the time to make a trigonometric substitution. So I put u equals what? Tangent. Tangent theta. Then du is going to be secant squared of theta d theta. And I can rewrite the whole integral in terms of theta. So let me simplify the coefficient. Square root of 31 cancels. That's good. And then I have 4, and square root of 8 goes on the top, so it becomes 2 square root of 2 divided by 4. So the number is very simple now. The integrand becomes what? 1 plus tangent squared is going to be secant squared, and square root of that is going to be just secant. So I have to divide by secant theta, and du will become secant squared theta d theta. And 1 secant cancels, so I end up with, well, 2 cancels, so I have square root of 2 over 2 integral of secant theta d theta. And they personally like cosine more. And now I'm doing the standard thing about trigonometric integral. Right? So what do we see here? We see the power of cosine. What's the crucial thing about the powers of sine and cosine? We don't see sine anymore.
That's the odd.
Yes, we are looking for odd power, and we have the odd power, because minus 1 is odd. And that means we do a substitution, right? We call it v. So what do we make this new variable v? If the power of cosine is odd, we better use v equals sine theta. Then dv is going to be cosine theta d theta. And if I artificially make that cosine theta d theta in my integral, I will multiply by cosine theta to make dv in numerator, but I will have to divide by cosine theta. My integral becomes in terms of v, the integral of what? 1 divided by cosine squared, right? In terms of sine, that is 1 over 1 minus v squared, 1 minus sine squared. That's what I'm using. So now I have to integrate this fraction. And again, I will talk in a few minutes about how to integrate fractions in general. But for this particular one, I told you that this fraction is very easy to handle. It's equal to a sum of very simple fractions. Those are 1 over 1 minus v and 1 over 1 plus v. And if you add them up, and you bring the sum to the common denominator. The denominator will be 1 minus v squared. It's exactly what we wanted. Then the first one will be multiplied by 1 plus v. The second one will be multiplied by 1 minus v. And 1 plus v together with 1 minus v will have v disappearing, and we'll have, well, number 2 left. So this sum is not equal to that fraction, it's equal to double of that. So in order to keep the value of the integrand, I have to divide by 2. So this is just algebraic manipulation of that fraction. And again, we will make it standard in a few minutes. But for now, I'm almost done. So I have to pull out this half. Half square root of 2 over 4. And then I will separate the integrals. Integral of 1 over 1 minus v plus square root of 2 over 4, integral of 1 over 1 plus v. And these are basic integrals. Logarithmic function is the antiderivative. So I have square root of 2 over 4 natural log of 1 minus v plus square root of 2 over 4 natural log of 1 plus v. And that one is right, but this one is not quite right. Derivative of this will be 1 over 1 minus v times negative 1. So I lost negative sign there. Put it back. I'm practically done, yes. So what I have to do is I have to go back to my original variable x. Right? How do I go back? I recognize what the v is in relation to theta. Right? So I replace v with sine of theta there. Then what is theta? Well, theta is tan inverse of u. I will replace every occurrence of theta with tan inverse of u. And then u is, in fact, that simple thing, right, in terms of x. So I will replace all the occurrences of u with that thing.
Might take a little bit.
Might take a little bit, yes. So it is in your interest to simplify this as much as possible. So I know that if I factor square root of 2 over 4, I will have the difference of logarithms. The difference of logarithms is one logarithm of the fraction. Logarithm of 1 plus v divided by 1 minus v. And then v is sine of theta. And then what's theta? Well, theta is tan inverse of u. And u is that simple thing of x. So you just put that simple thing of x right there as the argument of tan inverse. And that's it. And yes, sure. Plus a constant of integration. It should be even there.
Are we going to simplify that?
This?
Yeah.
Not for web assign. No. As long as this is correct, you should be fine.
Very nice.
I have to warn you that this is the longest integral you have on computational test.
Yeah.
To some extent, you see, to some extent it will be enough to check whether you can do this one. Because on the way of doing this, you have to do all the things you've learned so far, right? Substitution, trigonometric partial fractions